Hello everyone, welcome to the Compiler Reading Group. This time we covered Chapter 8 of Erlang, which just covers real-world use cases. In the chapter they covered things with the AXD 301, which was programmed by over 40 people, and the Bluetail Mail Robustifier, which is programmed with about 10 programmers that were all skilled. They found the results quite convincing and quite good. Just a brief synopsis of the chapter before we get into the main meat of it. This is roughly the amount of clean versus dirty code found. 0.4% to 0.8%, depending on the application that was analyzed, had dirty code. Dirty code is anything that just calls a primitive like send or receive, and pretty much any of these functions here. And what's great is that the majority of the code was fairly clean. 1/3 of the modules had some amount of dirty code, usually one function. They show a graph here. Most of the dirty modules had one dirty function, and some had like 30. Like you can see here, like a lot had 30. This was really troubling for Joe Armstrong, just how many little impure functions there were. But overall, I think, Erlang stood the test of time. There was a good quote about when he asked if the system ever went down, and they said, of course it didn't, because the thought never occurred to their mind. The applications were truly robust in practice. He doesn't have evidence for hot code upgrading going right because there's no error logs that spawned. Some people who used it, i.e. the blue mail people, had to write end state rollback instead of just the naive one that Erlang shipped with. But following with the theme of this chapter, we have ourselves a presentation. We have some Elixir and Erlang code we'd like to show off. And we're going to probably talk about how it's worked in practice, what worked, what didn't. And yeah, I guess I'd like to start first. I covered some Erlang code. Namely, I was working through the Narwhal mempool paper. Narwhal is a way of forming DAGs, a directed acyclic graph. And it could be used to make things like blockchains or whatever you care about, really. It doesn't have to be a chain. But it's quite nice in that it's set up as follows. You can imagine that there is a validator, and in a validator there is a thing called a primary node, which just checks signatures coming in. It gets signatures, and it's making a block. So it can get transactions, it can look up certificates, and it may have to sign a signature. And then there's another thing called what they call a worker, which communicates things over the network. The primary's job is not to touch the network, but instead just, do the role of verifying stuff. Whereas the worker, as they called it, is supposed to like work and send packets and do all the networking nonsense. Later in this paper, they make it, I think, even more interesting, where it's not just one worker, it's like a lot of workers. I don't know if in here, but the protocol has been extended to be like multiple workers. I didn't really care to model that because I would find that boring, to be quite honest. So what I did was model the primary, and I'm gonna personally be the role of the worker. And so some operations are as follows. You can get a transaction. Transaction just adds some data to the block. You can get a certificate, which is the last round's block, right? You can imagine that you're on round n, and n-1 has a block, so you just point to it. There's some pretty good properties the system has, but none of that really matters for looking at how Erlang performed. And lastly, you can sign other people's blocks, and you can only sign a block if they're on the same round as you. Now, without further ado, let's start looking at some code, because that to me is much more fun than going over specifics of a protocol. On the left up here, you can see the code. I kind of broke the code in what I thought was most natural. I have a validator block, so I call this my supervisor. So in Erlang, we have a notion of supervisors, so I just made the validator be a supervisor. It supervises two children, namely a communicator node and a primary node, which is exactly as the protocol lays out. As Joe Armstrong mentioned in the previous chapters, you should model your things one-to-one. That's how things work best. So I just have a primary and communicator that gets spawned. And I just have some brief modules on the supervisor just to get the PID of the primary because I want to like handle it myself because we can have multiple validators on the same system. Now, looking at the primary, what's really cool about Erlang is it allows me to do a lot of things. One thing that I neglected in the description is that during this protocol, there's two phases. A primary is either in a block creation mode, where it's creating a block, and it has to, get certificates from the last round and get transactions. At a certain point, if it gets enough certificates, it can make a new block. During this phase, it cannot make a new block or accept new certificates. Instead, it's just trying to get signatures from other validators who agree with its block being valid. And because of this, it has two modes. Erlang, I think, was really successful in making this work. I used Erlang's gen state M. If people are following the paper, they use state FSM, but that's deprecated as of OTP 9. So we're using gen state M, and it uses the state functions for callback. What's really neat is that we could actually see what messages this code accepts trivially, right? Because the callback mode is state functions, we just have to go down to functions of the same state name. In this case, we have block creation and we have signature collection. These are the only two valid states of the system. It just dispatches to the right one. So when we init the network, up here, it puts it in block creation mode with the proper config. And so when this code gets a message, it just goes to block creation. So if we get a message, new transaction, this thing, block creation will be called automatically for you. And when the state transitions to signature collection, these functions will be taken. And from this, we can see the total functions that each of these accept, right? So if I'm in block creation mode, I can take new transactions, I can take new certificates, I can sign a block, and I have a get state command, which will be useful just for dumping state. And then if it's not any of those, I just handle the unsupported. You don't have to do this. Joe Armstrong suggests you don't do this. However, because I want my state to be resumed from the last one and I don't have state that updates set up, will restart with the initial state, I have to be a bit exhaustive in this. This should be deprecated as better state initialization is had, right? Because I need more persistent state on startup rather than what is given to me by default. So this is just something that I guess Erlang could have made just a tiny bit easier, but nonetheless, it's something that's easy enough to do. And for the signature collection, it takes a new signature, it can sign a block, and it can get the state. And then I have something to handle the unsupported call. And that's all. This is basically the entire functionality. The rest of this code is just supporting this core functionality, and then I have the client functions, which just send the thing. Oh, have a new transaction, call new transaction. Have a new certificate, call new certificate. Call new signature, call sign block, get state. In a real productive system, you wouldn't be calling this, but your client would, right? Or what they called your worker, and which I'm calling the communicator. Your communicator would talk to you and tell you, hey, here's some things, and that would be the translation there. So I kind of want to show you how the system started. So what's really neat is that since I have a supervisor, I can start a link. So when I say this, I can say NIST narwhal validator, and I can start the link. And this just starts a link, and I give it, just give it some data. So you can see here that I have a PID and an OK. This is great. So now I have the PID of the validator. I can inspect it if I really wanted. Inspect PID. It tells me it's a PID. That's not so useful. But I have another function here. So I have validator. So I have get primary, and if I get the primary of PID, whoops, I misspelled because I'm bad. I have the primary now, so I can call this the PID, the PPID. And now we can start doing stuff. In particular, I want to kind of show you the life cycle of some functions. So if I get a new certificate, so I guess I'll mention some things before we get started. I don't do any validation of certificates. So when I say I have a new certificate that is 5, this is, of course, nonsense to the protocol, but since I didn't implement it, it's okay. It can just act. But what's cool is because I have a thing called get state, I can just dump the state, and it will just tell me, like, oh, hey, here are the certificates, 5 and 5. Here's a transaction, and here is, like, here's my private key. Here's my public key. We're on round 0, and we've not signed any blocks. But what's really cool is that I can start signing some blocks, right? So I can now make a new PID too. So if I get one more new certificate, I believe I did that once. Did I do it once? I think I do this. So this is the last one, V582. So I want, okay, signed block is equal to V582. So now I have it called signed block. So now I have the signed block, and I'm going to start up a new validator. And so I'm just going to do it this way. So I'm going to start a new link. I'm going to add the PID2 here. And then I'm going to have it sign the block. It actually does do block signing checking. And what's neat is that since we signed the block, we can actually get state of PID_2. And we can see that part of the protocol is that you can only sign one block from a validator once. So I have here a public key. This is the public key of PID, and it knows that, hey, we can't sign another block from it. So if I were to try to do this again, if I were to try to sign the block again, it would give me back an error because, you can't sign a block twice. That just violates protocol. And it also remembers that, hey, this block that was created, here's the key of it. So it's really neat. So it actually knows that if given this digest, it knows what block it's in, right? It actually knows the blocks. I'm not seeing the digest here. It looks like it's just mapping this to this, but I believe I keep that somewhere else. But it does store the digest. And if we get the state of PID2 of PID, we can see that it has a hash table of its own with blocks where it saves the digest to this map here, which is really neat. I can actually just inspect data and I can see what state we're in. And one interesting to note is that there's 2 states here, and in the first state, which you can see PID2, the data is a record of certificates and transactions, where after we make it, it just has our block that we stored and the number of signatures we get. And since I signed a block, I can now tell my primary that, hey, you have a new signature waiting for you. Right, I'm acting as the communicator. And when we dump PID again, we can see that, get state PID, it should have it in the signatures. You can see here that it has the signature, it has the public key plus the signed data. And so once it signs it enough, it works. I don't check for duplicates because it's easier to show. And so if I do it twice, you can see it. I have it just push to a list because, yeah. And then when I do it 3 times, it finally goes over to the next state. So it just returns the block, and now this block can be valid for the next round of signings. And if we were to get the state, and if we try to sign again, it says this is an unsupported message because, we're no longer in signature collection anymore. So if we get PID, we're off to make a new block. Which I think is kind of neat. So yeah, that's roughly how the code works. I can actually show you some of the details. That's just using the code. But what's kind of neat is that it was really easy to implement crypto things. Like, for example, I wanted to check signatures properly. I didn't check certificates, but signatures, I wanted to make sure they were correct. So one thing that I made sure was that before signing an external block, I had to make sure that it was properly signed. And to do this, I have a function called sign if valid, and basically I check if it's in the sign set. So, I can't sign a block twice. I check if it's a valid signature, and I check if the rounds are the same. For it to be a valid signature, I basically take the signature given to me, and I take the block, and I make sure that the person who gave me the signature signed the block, right? So when you're handing it out, the block should be signed by you, so you should have the private key for which signed it. In another model, you may have, when I'm sending out blocks to be validated, you end up needing a public key. What's really neat is that this is the same function, but it just allows me to overload what's happening depending on the context, which is really nice. But overall, I would say that Erlang here worked really, really well. I use a lot of type signatures. I use a lot of word types, and I sign a lot of my functions. It's quite nice because it can tell me when things roughly go wrong, because dialsalizer works fairly okay. But I think the code is incredibly simple, right? You just pattern match the types you know of. Like, I know I'm getting a signed block. Well, a signed block is a tuple of a block structure and some binary data. Well, okay, a block structure is a block with the public key. What's a block? Well, a block is a transaction plus certificates. And so I was able to do like normal programming, and it just worked great. I used hash tables and all that, and it just kind of allowed me to understand how to sign blocks quickly. I even have an example here of like signing blocks without making a actual validator. You know, you just run the code yourself because it's so easy to generate crypto keys. That, oh hey, look, I just generated a public private key by calling crypto generate keys, and well, I'm gonna make up a bullshit block and then I can sign it, right? I can do weird things like signing this because I have a private key, and I know the private key relates to this block here because the public key is in it. I could technically create a signature for it, which is quite nice. And then, you know, you can end up signing the block. So, you know, you tuple this back up because now I signed it. So I signed this block with the private key, and now we can just sign it, and this one gets an error. Yeah, because, yeah. But I think it's just really neat how that works. I think one other thing I want to show everyone here is that there's this really great thing called Observer. And what's great is that if I look at the PID, and I think PID underscore 2, so 13071.16, I didn't name these anything. But what's really cool is you can look at memory and you can look at applications, but if I look at the memory addresses and I look at those things, PID, it's 13071. I still don't know how to like filter this 13071. Here it is, 13071. This tells me that this thing is current function, the message is nothing, the dictionary is there, the stack trace the state. Okay, I'm going to expand it, and it tells me that the communicator is on this address, and the primary is on this address. If I click it, it tells me what this is. It tells me the state. Notice that I didn't need to use dump state, because Erlang just allows me to see it like this, and it has a few printers for it. Not all these printers are great, but as you can see, it's very nice in that I actually don't need to make the get state function. This just tells me the information about it. And it's quite nice because it tells me, hey, it's still running. The status for the state machine is this. Okay, it's a gen state M. It's called the module's primary. It has not experienced any timeouts. There's no timeout functionality. Here's like the stack trace that it's currently in. You know, oh, here's the starting call, and some ancestor nodes. I'm guessing this is its supervisor, I believe. And yeah, you can just see here that it tells me what functions the error handler. Here's some binaries for it. And yeah, I would say Erlang was very effective. This code is about 481 lines of code. I mostly just paid attention to the spec. Everything fell out of the spec. There's some questions I still need to implement. Like, there's a lot of things that I could fix. Like, instead of using a list, I can use a set, and that would fix the multi-signing issue. But overall, Erlang made it really easy for me to just look at a piece of code and just like write it. It looks ugly. I think Elixir in particular is an ugly language, but it doesn't matter because the Erlang model of computation worked, right? I could just do this. I have a REPL to ask it questions. I can dump state, right? Like I can just, ask it questions. I can get the state of things. I can look at it. I can see data, and I can get up and running instantly, which I think is the most important part of doing anything. And lastly, I also made tests for it because Erlang is very good at what it does. I was managed to, from my interactive script there, I made tests to make sure that certain behaviors produce errors. And I also noted that when I do proper checking, these likely will violate the specification. But it's okay because I can just do this and I can just change it when it comes. It's really nice that you can just make tests like this, and it just works. So yeah, that's pretty much, I guess, the end for this presentation for the Elixir code. Does anyone have any questions or comments about it? Okay, cool. I guess I'll hand it off to Ray in a second. I guess I'll just mention one more thing. In chapter 8, Joe Armstrong mentions dirty versus clean modules. All the modules here are not dirty, they're clean, even though they're impure, because the way that he defines dirtiness is quite realistic for real code that needs concurrency, and I don't actually violate any of his primitives. So that's just something to note for people who've read the paper. Let me stop sharing my screen. You're presenting. Stop. I guess, Ray, you have the floor.
Cool. Let me present then. All right. Okay. I'm assuming that's showing up properly. Okay, so yeah, the following reflects about 2 hours or so of work that I did one Saturday. It's important that it was like 2 hours because my main goal was to see how quickly I could, prototype some protocol logic just using Erlang gen servers specifically. So this was like 2 hours of work, most of which was spent constantly cross-referencing the documentation. So more like 1 hour of work for someone who's using this stuff constantly, I would estimate. So what it is the protocol logic for a hypothetical IRC daemon. This ended up taking up 2 files. One represents users, one represents channels. Both are gen servers. And the behavior gen server literally just means that it's some module that exports a certain interface, right? This second export statement here is precisely that interface. That's why it's in its own export statement. So to be a gen server, you need to implement init, handle call, handle cast, handle info, terminate, and code change. All of what you can see below. Start link is just it's something that calls gen server, right? It's kind of a standard name for starting some process and linking it to whatever started it. In this case, it's pretty much always going to be the Erlang shell because I'm going to be starting them from the shell. So the idea here is that IRC user is sort of it takes IRC protocol command, right? You imagine some hypothetical translation layer that from the text IRC protocol that you get over some TCP socket, and it just does a dumb translation of the text protocol into Erlang tuples. And then IRC user is a gen server that handles this these messages like as the representation of the user within the whole system. An IRC channel is also a gen server, which represents a channel which doesn't have like an associated user or anything, but it is its own like object at the protocol level. And the way that channels work in the IRC protocol is they're basically just multicast groups with some associated metadata. So the core concept of the IRC protocol is you have priv message, which is just private message. It's actually the only type of message. It can be sent to a user or a channel. And if you send it to a channel, then what the protocol does is just repeat it to every user joined to that channel. It's a pretty simple protocol. So if I do a demonstration in the shell, it starts out something like, well, let me make sure that I've compiled the latest versions first. Compile IRC user, IRC channel. Okay. So the first thing, like IRC user, and I give it a name. I'll name this user Ray. And okay, so I have a PID. 0930 is the PID of Ray. Here I called gen server start link. I gave it global NIC. So what this actually does is it registers the name with the Erlang like global name registry for processes. This is like a very bare bones lightweight global name registry. All it does is just map names registered. Global registered name. All it does is map names to PIDs. Global where is name. So I can, if I have the name Ray, I can look up. Okay, that name maps to PID 0930. And it's pretty useful because in all of the gen server methods that the system provides, you can just give it one of these global names and it will do the lookups for you. So I relied on that a lot to not have to deal with PIDs in the code itself. Okay, so now I have an IRC user running under PID 0930 named Ray. So let me. The first thing I can do with my user is I can send a message. I'm just using this IRC user priv message. This is literally just a helper for the REPL, so I don't have to do all of this typing of gen server call, global, et cetera, et cetera. So it's from Ray. Okay. Content is hello. Okay. And what actually happened there? Gen server call. So the first Ray is the like this the gen server that we're invoking something on, right? So you can imagine that a hypothetical translation layer that's holding a TCP socket from the user Ray, got some text command and it turned it into a call to the IRC user process named Ray. And what's the content of that? Priv message target message. Okay, so the call is handled in handle call. In this case, so the way that this works is just pattern matches. So if we scroll down the pattern matches, the one that actually matches is this one, right? Handle call command target message when command is priv message or notice. The reason I use this guard here is because the IRC protocol has priv message and notice, which are two commands that have exactly the same semantics, but one of them is called priv message and one of them is called notice. The reason this exists is it's meant to be that any like automated reply is required by the RFC to be a notice. So like any bot or any server generated message is required to be a notice. In practice, people program their bots to send priv messages, which is bad because the reason that it's like that is that you then additionally have the rule that no bot can trigger off of a notice, and so you don't end up with infinite bot loops. But because people program their bots badly, infinite bot loops do sometimes happen. Okay, so what actually happened with it? This matches, it matched, priv message, Ray, hello, is our command target and message are. So for the source, we get the state, right? The way that state works in gen servers is the state is always a parameter passed to all of these various handlers, right? So handle call is the actual message, the source of the message in case we care about it. In this particular case, we don't. So that's why the pattern has that underscore in front. So what is the state actually? So in init, we set it to use this state v1 record. So I said init Ray when I started this gen server. So it's, make is Ray, user J, host is irc.local, real name is IRC user. Modes, this view mode I. Here's the record definition, right? State v1 is just nick, user, host, real name, modes. So like a record in Erlang is literally just a syntactic macro. It just gives names to a tuple fields. It's secretly just a tuple underneath that carries its record name. So like if I type this, it's got that as the head, and then so whenever we have one of these state records, it actually looks something like this. The curly brace being, starting a tuple, the square brackets for a list, and then all of these just words that start with lowercase are just atoms. It's just ABC is the value ABC. The way that Erlang distinguishes between those and variables is just that variables start with a capital letter, so ABC. But I could do bind variable ABC to that atom. Okay, so returning to handle call for a priv message. So it didn't match this earlier thing. This earlier pattern is for messages to channels. It requires that it start with the octathorpe, which indicates the channel name. So what do we actually do? So I use global send. Global send looks up the name from the global registry and does a send. So like the syntax in Erlang is like I just sent the atom message as a message to this thing. It's an unknown message, so it doesn't actually handle it. But that's the syntax for sending to a PID. Global send just does that. It combines that with a lookup of the name. Right, so I have my target, which was also Ray, and then command source message. And so what that actually resulted in is handle call. Handle call did this debug printf, and then when it actually received the message, this was in handle info. So handle info, when you have a gen server, you can do gen server call to send it a call message, which is just like an RPC call. It has a reply. There's also handle cast, which is the same thing, but it's for like a command. If you send a cast, you don't expect a reply. You're just sending something. And then any other message is handled by handle info. So since I just sent some other message that wasn't a call or a cast, it goes to handle info. All this does is it debug printfs everything. So that's why I got this. For something more interesting, start link. Another IRC user named Bob. Now, Ray can send to Bob, hello. Okay, Ray priv message to Bob, hello, and then Bob prints priv message from Ray, et cetera, et cetera. Okay, so this works, right? It's kind of boring. State never actually changes in any of these. Probably if I ever extend this, the user will not be quite so stateless. For one thing, users can change their own modes and so on. But for now, like pretty much everything just returns the value, reply okay state. What's more interesting, however, are channels. So let me terminal over here so the channel can be the focus. More interesting are channels. So I'll create a channel named IRC. Okay. So the state of this is, it has a name, a topic, it has modes, has a list of members. So that's the state. So, the first interesting thing that can be done is a user can join. So Ray can join IRC. Okay. You see here, the IRC channel, the IRC channel process noted that Ray joined, and Ray also debugged printf that he joined IRC. So I have who, which is it's a real IRC command, but I'm mostly using this for debugging, just to list who is on the channel. So this is what the channel knows in its state. Now this handle call is a bit more interesting because we receive, join. We have a nickname and their user host. We also have their PID. Handle call tells us the source of the call, which is an Erlang PID. It also includes a tag, which is like an identifier for the specific message that was sent, so that you can reply to the specific message in some way, and then the state is passed in. What we actually do is we construct this member record for the member that just joined, and then we actually build a new state. And then after we send the joins to all the members, what handle call returns is reply okay new state. And this is how all of these work, right? Every gen server method passes in an old state, and it returns a new state when it's done. So let's have Bob also join the channel. Okay. See, Bob joined. And now if Ray and hello channel, the IRC channel. Okay, we see this is Ray sending it, and then Bob and Ray both received it. And this was actually very simple on the channel side, right? So if you see my comment, this gets complicated when I actually want to implement all the various modes that a channel can have. But the core of what the protocol wants me to do is when the channel gets a message, the channel repeats the message to all the members, and send to members is literally just for each member in the list of members. We find their PID and we send the message to it. That's it. The exclamation mark is just the Erlang send message operator.
I have a question.
Yeah.
Why are these calls not casts? Are you returning some value that the sender cares about, or?
I guess they could be casts, except when the protocol is done in full, some ways of sending messages are invalid, right? For example, maybe I implement, the +M for moderated channel mode, and someone sends a message to a moderated channel they can't send a message to. In that case, I do need to return an error numeric per the protocol. So the good case for all of these doesn't involve returning messages to the user. If you say from just the IRC text protocol perspective, if you send a message to a channel, it doesn't get echoed back to you. So in the good path, you don't actually get any return value. But if you send a message to a channel you can't send a message to, you do get something back from the server. You get the specific reason that you couldn't send it to the server.
Sure, but
some things would make more sense as casts. Like, for example, a nickname change, right? There is a when you're trying to do a nickname change, you might receive an error reply saying nickname is already in use or something. When someone has done a nickname change, that's just an announcement from God, basically. It's just this nickname change has happened. If you need to do something to deal with it, you need to do that thing to deal with it now.
Yeah, that's fair. I guess the only complaint that I would have is that this would block whatever is there, right? Because while you're waiting, you can't actually do anything with the Ray user because you'll be waiting for a reply, and you can imagine maybe if the channel is for some reason under heavy load or something, you'd be stuck there, and you couldn't actually handle the next request to send a message. That wouldn't actually.
It doesn't particularly block. No, it's just the same as any other gen server method. The call and cast don't really differ.
They do
in how they work.
No, they do. Call is synchronous and cast is asynchronous. When you do a call, it's actively waiting for a response. Whereas if you cast, it will actually just send it and then keep going. It'll just execute the rest of the logic. but if you call, it will wait to get a response before continuing.
Yeah.
Yeah.
Yeah, so it's possible that you might want to do that and then just asynchronously handle numeric replies from the thing. To me, it seems like that would make more sense at the connection level, maybe. It
Probably.
might make sense at the interprocess level.
Ye-
It depends on how you organize it, but like the message has already been received and processed by the system. Or like the user's TCP message has already been received and processed by the system by the time you reach this. But yeah, there are concurrency considerations here. Yep. You had a question?
Me or
Okay. Hold on. Did someone have a question?
no?
No, no, someone. Okay, later. See you later then. So, but yeah, that's a lot of them could be casts, I guess. I mean, info's channel doesn't really have any info that it will hold because the only way that a channel gets interacted with is by a user and so on. So the obvious ways to extend this, if I were willing to put more than like a couple hours of work into it, which maybe I will, I don't know. The obvious ways to extend this are just to implement more and more things. And the development process in Erlang is very straightforward and easy in the sense that, I don't have to particularly do anything. Right. If I, just like as a stupid example, if I like change one of these debug printfs, say, right, I can just hot reload it right there if I just, okay. Yeah, see, I can just hot reload it and my new code is running. I have the stupid letters that I added, take them back out. The only thing I do is just recompile the module. It hot reload with the existing gen server. I could implement more than a stub in code change if I wanted. This would be like if I changed the state format for the gen server between versions, then I could write an updater here. It's like this would be important for hot upgrading, an actual running IRCD, which is if I wrote the TCP layer, then what I could do is just have some real IRC clients connect to it and continue to hot upgrade it and work with it. Writing the actual TCP layer because it involves making TCP sockets. Erlang's Gen TCP library is not difficult to use, but it's considerably more difficult. It could be another couple hours just to get the connections up. But if I did choose to extend it, that would probably be the obvious direction, and then actually implementing more protocol things. Like there's a lot of random to-dos. The channel thing, for instance, priv message doesn't particularly handle any modes, right? I gave it the usual default channel modes of N and D, but actually, it'll change it doesn't handle those at all. There's more commands that both channels and users have to handle. I probably want to use something more powerful than the global process registry because I want to go bidirectionally between names and PIDs, and I want to be able to change names sometimes because you can change your nickname on IRC, which is made slightly. I could actually implement that using global. I would just have to unregister the current name and register the new name. But sometimes I also want to go backwards from a PID, like something that I got. If I got a PID and from, I don't have a name and from. Right, so I might want to reverse look that up. And yeah, other than that, just implementing the various, channeling user modes, right? I'd need to implement who is, and then, the I mode, which is usually default, and its default here. It's supposed to hide you from like a channel list. So the fact that I can do like IRC, this should actually not show them to people who aren't already on the channel seeing them, for example. So there's a lot of protocol semantics that I would want to spend time implementing, but I could spend time implementing those on a running IRCD with clients connected to it. And the only thing that I need to implement for myself is Gen server. Oh, and the other thing I'd need to do is have like an actual a third file here. It could be the IRCD process that would supervise users and channels and just start them as needed. For this example, I just manually started all the users and channels and processes, but what should happen is the user should be started by the supervisor. When a TCP connection comes in and a user claims some nickname, and a channel should be started. So in IRC, channels just they don't exist until someone joins them, at which point they begin to exist. So the IRCD would need to receive joins to channels that don't exist and create those channels should they not exist. So those are the directions to take this in. Wait. All right, I will take any questions from that if you do have any.
I don't have any. So actually, I guess I do have one actually. What happens
Yeah.
if a user joins a channel that doesn't exist yet? Would it just like error because it's not in the global registry?
Yeah, it would error. It would just yeah, it's I could actually I already stopped sharing the screen, but I can reshare it to give an example. I'll just share the X term. Join.
So is
And then yeah, it just
that's a pretty good crash report.
yeah, got a pretty detailed crash report here. It's the reason for termination is no proc. So there's no actual process that I tried to send a message to. So Bob terminates here. There's no Bob supervisor written yet, so there's no Bob supervisor to start the new Bob. But yeah, you get like everything would be dumped to the supervisor. If the supervisor existed, in this case, the supervisor is the shell, so everything got dumped to the shell.
That's quite nice. That's better than I don't think I get crash reports like that in Elixir. I'd have to check, but I don't remember seeing something this nice.
They
But
might just be hidden.
I don't know why you'd want to hide this. This looks very nice. Like I remember getting like crashes where things would crash, but it wasn't like this nice
Yeah.
where it literally says crash report and then it dumps to me the
No, yeah,
same thing.
it just has all of the information. Yeah,
Yeah, that's quite nice.
and yeah, the Bob supervisor here was just the shell, so the shell got the stuff dumped to it.
That makes sense. Yeah, it looks quite nice. Did you have any snags while writing this? I guess there's only a few hours of work, so you probably didn't run anything. But have you run it? Have you stopped?
Yeah,
Yeah.
there were not really any snags writing it. No. Yeah, it was pretty straightforward. Like the way that Erlang is just sort of like it's a pretty considered decision to just have everything be tuples and atoms at the base level. It's like if I have some foo message, right? I just do a tuple like foo message data. This and then pattern matching on those. So it's pretty rapid, right? There's no bookkeeping step for me to just handle some new type of message. I just think of the new type of message that I want to handle, and then I add a pattern match for it for handle call or whatever.
Yeah, that makes complete sense to me. Yeah, the protocol has stuff for upgrading your types, so you using state 1 versus state 2 makes sense even, so
Yeah,
yeah.
yeah, that's not an Erlang pattern. That's a pattern that it comes from Urbit, where you just have you number your state type, and then it's very easy to write the state upgrade functions because they just match on what state type it is and run the particular thing. So like if you're upgrading from state 1 to state 5, it can easily just match on them and run each of the upgraders in turn, right? So it'll just recursively call the state 2 upgrader and then the 1 to 2 and then 2 to 3 and then 3 to 4 and then finally 4 to 5, and then that will be the one that's just identity, and then you have the new state.
Yeah, makes sense.
So that's an Urbit pattern, and the way that you write things in Urbit is kind of similar in terms of you just implement some interface like Gen Server. A lot of things are pretty similar. Urbit is more of a CQRS thing. So like Urbit kind of only has casts, and then to receive things from some process, you subscribe to it on the pub sub bus.
I was actually just going to ask how this felt like or unlike what you would have done in Urbit.
Yeah. Yeah, Urbit is very CQRS, which is command and query responsibility separation or something like that. So you cannot do like an RPC call to an Urbit process. You can only you can send it some data and get no reply, and you can subscribe to get information. If you poke an Urbit thing with data, you can either get an ACK or a NACK. The NACK contains a stack trace but it doesn't contain like a failure message or anything. It's not a real reply. It's just NACK and here's your stack trace.
Yeah, that makes sense. Yeah, I guess on my end, I found Elixir was very nice. It took me a bit more time to model what I was doing, just because I found reading the protocol a bit hard because it's not the greatest, to say the least. But I still found it. I found Erlang stayed out of my way for the most part. I ended up like formatting like types a bit wrong a few times, but that's more of Elixir specifics annoyances rather than like Erlang,
Yeah.
which Erlang I think does a better job at doing that kind of thing.
Yeah. Yeah, Erlang has a pretty simple syntax. I think some things like records might get a bit verbose because it's always like you have like variable name and then record type you're interpreting it as and then field every time. But it makes sense because they are just macros over tuples.
Yeah. Okay. Cool. Does anyone have any, I guess, questions for the presentations, like either of them, before wrapping up?
I know Erlang has some maybe extensive metaprogramming features. Did you end up using any of them or looking into any of them?
Not particularly, no. Mostly I was just having.
Sorry, I meant Elixir.
Yeah.
Sorry.
Oh yeah, Elixir.
It has some. I don't really use it too much. The problem is that like it's not fully homoiconic. I don't know actually how to macro expand things, which makes me a bit uneasy. See, normally I'm used to just like macro expanding stuff. Like I used con, which is a macro, but overall, I just kind of used the macros given to me. I didn't actually make any new ones. I guess I did once because I found types were a bit annoying, just due to how they were defined. That ended up getting in my way. And types don't appear if you import a module because they don't exist in the Beam cross modules. That's why you have to like import it and require it with a name. And so to properly like define a type and open it, you would have to use a macro, but that's kind of an anti-pattern, so I didn't end up using it. But yeah, I didn't really use it too much. I just wish it were a Lisp. Like there's no reason other than for popularity's sake that Elixir is the way it is. I wish LFE, Lisp flavored Erlang, had better docs, because I would personally rather just use LFE, because why wouldn't I just use a Lisp? Lisps are just superior. they just give you power for no downside, really. So to me, it's just a bit disappointing, I guess, on Elixir's side that it isn't a Lisp.
I see.
No.
Ray, I should probably let you finish the answer that you gave to the question that I didn't mean to ask. I interrupted you.
Yeah, I mean, Erlang macros. I think the Erlang macros are just pretty simple for the most part. Most of the macro-like functionality that's complicated is just provided by Erlang. Like records are a pretty complicated macro, but they're just provided by Erlang, for example.
Yeah.
Well, cool. Thank you both. I don't think I have any more questions.
Great. With that, I'll wrap up this recording.